Wheel and axle calculations. I'm going to read your problem and then we will work through it together. An industrial water shutoff valve is designed to operate with 50 pounds of effort force. The valve will encounter 400 pounds of resistance force applied to a 3-inch diameter axle. So we first want to sketch this. A valve consists of basically two cylinders, two circles, the inside one and the outside one. We're going to end up with this problem like we do with basically every mechanical advantage problem. We're going to have a force of the resistance, distance of the resistance. We're going to have the force of the effort and distance of the effort. Reading this problem again, the industrial water shutoff valve is designed to operate with 50 pounds of effort force. Well, that's pretty easy. Effort force is 50 pounds. The valve will encounter 400 pounds of resistance force. That's also simple. And it says that the 200 pounds of resistance force is applied to a 3-inch diameter axle. So the distance of the resistance is 3 inches. So putting this into our picture, the diameter, symbol for diameter is like so, of the resistance here is 3 inches. The diameter of the effort, we don't know what that is. So that's our picture, and we have labeled our forces. We could put those into the picture as well. I guess I will. We're going to have the effort force, and then we're going to have the resistance force on the inner circle. And the effort force was 50, and the resistance force was 400. Probably put too much stuff in that picture. So first question, what is the required actual mechanical advantage of the system? Well, like always, to find actual mechanical advantage, which is what this is asking, simply take the force of the resistance divided by the force of the effort. In this case, the force of the resistance is 400 pounds. Force of the effort is 50 pounds. Pounds cancel. And we're left with actual mechanical advantage is equal to 400 divided by 50 is like 40 divided by 5, which is 8. Actual mechanical advantage of this system is 8 to 1. Second question relating to this problem. I'll call this part B. What is the required wheel diameter to overcome the resistance force? Well, what that's asking you to find, the wheel diameter would be the diameter of the effort. It's asking for the distance of the effort, or diameter of effort if you want to call it that. Well, this is done just like we've done for other problems. If you watched those videos first. In order to achieve static equilibrium, the moment of the resistance has to equal the moment of the effort. So if these were equal, then it would be in static equilibrium. We need to figure out what the minimum diameter would be so that we could actually turn this with a force of 50 pounds. So we take the force times distance of the resistance, and that must equal the force times distance of the effort. Force of the resistance is 400 pounds. Diameter of the resistance is 3 inches. Force of the effort is 50 pounds. Diameter of the effort, or distance of the effort, we don't know. 400 times 3 is 1,200. 1,200 inch-pounds. And of course on the right, there's no calculation to do. To get distance of the effort by itself, I'm going to divide both sides by 50 pounds. On the left, that would give us 1,200 inch-pounds divided by 50 pounds. On the right, we're just left with the distance of the effort. On the left, the pounds cancel. You divide something by itself. That gives you 1. 1,200 divided by 50 is 24. The only label left is inches. The diameter, or the distance of the effort, needs to be 24 inches. Make sure I answered the question. The question says, what is the required wheel diameter? We've been using diameter this whole time, therefore this is in diameter. So 24 inches, or you could say 2 feet. But probably want to keep it in the same units we've been using for this problem.